Hello everyone, this is Ali Reza. In this episode, we will do two things. First, we will draw the connections. Right now, we are making connections. But honestly, who knows which output is connected to which input? Which node is connected to which node? There is no way for that. So, we will first draw our connections. Then we will make a right-click menu here on our outputs and our inputs to break connections there on each one of them. Okay? So let's get busy. To draw the connections, I will uncomment this draw connection inside node schema GUI. Then I will come down and where I'm drawing when I'm putting these schema partial classes under the graph in comment editor, I will create a class and I will call it node schema draw connection. Okay, and of course it's partial class blah blah. And our method is draw connections. Now, draw connections is again a private void. There is no point in making this guy virtual or protected. Draw connections, and that's it. Yeah, we are drawing connections. Okay, if not null, if inputs equals to null. Or inputs dot any is false. Remember when I said 2 videos ago that from now on, whenever we want to do anything related between two nodes, we start from input and move our way backward? This is one of them. We are checking for our inputs. If we have no inputs or the inputs are empty, then return. There is nothing to draw here. Then we say for each inside inputs var input, we say if input dot parent parents equals to, I was debating on using any parent, but no, or input dot connection equals to null, or not input dot connection dot list dot any. Well, I'm dumb. This is if parents dot any parents, if not any parents, or the connection is null, or the connection list is not having anything, or input dot connection dot list equals to null, or this. Then what we have to do, we just continue. It means that this input has nothing, it's somehow corrupted, we don't want anything to do. Then we say for each inside input dot parents, and we call it parent. Now we say if parent dot outputs equals to null, or instead of all of this I can say any if outputs equals to null, I don't have any helper method for that, or not parent dot outputs dot any Then we simply again continue the second loop. And now we are ready to start stuff. First we say list of come on, what's wrong with you? Connections inside Buzz MMO graph IO, or no, actually I want connection key. Okay, and yeah, import collections generic, we call it input key equals to input.connections.list, and I could totally use var here, but meh. Then we say list of int, come on, and we call it output indices equals to input key dot first t goes into the condition of t dot has key for parent dot related node dot id dot values. After that we say for inside our output, for I, inside our output indices dot count boundary, we go well, here I can get help, and where was my graph schema? I'm drawing this guy, so I can paste it here, import. Now instead of active output we have parent dot outputs of I that position, and equals to our input that position. But I'm doing something here. I'm saying start dot y plus equals 1 pixel. I'm moving it toward the center. And here I will say end dot y minus equals to 2 and end dot x plus equals to 1. Then we have start tangent, end tangent, color. Now for the color, I say editor GUI utility dot is pro scheme. If that's the case, I will use color color dot gray. Otherwise, new color of 0.8f, comma 0.8f, comma 0.8f. After that, the offset, well, one more thing. If is selected or the parent that is selected, I will overwrite the color. So we say color equals to new color of 1, comma 0.5f, comma 0. Boom. Then we get the offset as before. If input dot position with capital P that x, the same stuff, else the same stuff, and the same stuff. Okay, you ready? Build solution. Going back to Unity, let it compile, and suddenly, bam, you see every connection. So now you see how the nodes were connecting to each other. So this input gets output, 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 output. This output connects to this input and this input. And you see the orange color because, well, I'm right now not using the color overlays for the nodes themselves, but more than one node actually right now is selected, and I can confirm it by coming into here. And if I open, where is that? Selection node, you see that at least one node is selected, okay? And this node is the one that its output is connected to two places. So it's this node, actually. So this node, that is the last node I created, remember, is the selected node. And because it's selected, it's drawing its own connections like that. And because it's drawing its own connection toward this guy is also drawing its connections like that. Okay? So we draw our connections. Now we want to break the connections by a context menu. It's fairly easy and fairly fast. Okay, so I will make another class here and call it, what should I call it? Node schema context menu. And well, like before, not this one, like this one. Copy this, it's the same partial class, Control V. In connection, now, actually not here. When I'm drawing the input connections, remember, we had this process context menu. And when I'm drawing the output connections, we have the same process context menu. Okay, now it's time to make this guy. So the context menu is private void process context menu. We say if parent graph equals null, I like this sanity check, return, do nothing. After that, we say generic menu. Menu equals to new generic menu. Menu.add item. New GUI content. Come on. Break connection. After that, it's not selected, false, and context menu, well, context callback that we don't have yet, comma, connection button. Remember, we wait, we are not saving it here yet, I think. Where's the connection button? Didn't I assign it to the node schema? Node schema. Well, I have it. Sir, I missed the C there. Okay, connection button. So remember, when you are putting something like this, then you say menu.show as context, and here we say event.current.use. Okay, time to make this guy. No, I don't want to import the system.threading. What I want to do is actually make the daemon method. So private void call context callback, but remember, it accepts an object of obj. Here we say var node input equals to obj as node input schema. Right now I'm not sure if it's the input or the output. So I start with one of them and check if the node input does not equals to null. If that's the case, we simply say break input connection on the node input. As simple as that. Else, now if it's not input, then we are sure it's output. So we say var node output equals to obj as node output schema, but still it worth checking if the node output does not equals to null. Then we say break output connection on the output, on the node output. Okay, and at the end of the else statement we say cursor dot visible equals to false, and node editor, oh, we don't have that. Node work view, that's what I want, and I don't have it. So remember on our schema GUI, I think I was setting it somewhere. No, oh, the schema. No, where was I drawing it? Graph schema, I think. No, that's not that. Come on, where are you? Show your face. It's somewhere around here. Huh. Where was I drawing the mouse? Well, it's not in this guy, it's what the heck? Am I getting old? Damn it. Where was that? Inside. Is it here? No. Okay. If you don't know where to look for, there is a way. Where's my node schema? Oh, wait. Okay. There is this hide cursor usage. Find usages. only? Then why, when I'm right clicking, I'm losing my mouse. Okay. Well, wait. We have a reflection utility. Updating my brain. We want a singleton field to be set. If I remember properly, height cursor is a field. Yep, and the singleton is the field. Okay, so yeah, totally lost. Here we are. We say reflection utils dot singleton name field object value. Singleton is property. Okay, so the first thing is the type, and for the type, well, we don't know. We say reflection utils.get type node, what do they call it, node work view or work view? Graph work view. Look at me. Okay. Graph work view, comma, the namespace for it is this guy. Okay, now that we have the type, we want the singleton name. Well, the singleton name is instance, if I'm right. Yep. And then we want the field name. The field name is height cursor, and then we want the value that is false, true, and then the singleton is boolean or not. It's not boolean, it's not singleton, and binding flags are the same. So yeah, okay, that is it. Let's build solution, and let's hope it's working. So coming back, if I right click here, I get that break connection, and you see that my mouse is getting hidden. Now take a look. I break the connection only on this output. It removes this input from himself, but then checks this input and says, oh, this input has more connections, then yeah, whatever. Now, if I break the connection on this output, I get something very bad. Something really, really bad. That shouldn't happen. What is this guy? One of the places that I'm using first. Okay. Did I miss something here? Draw. Well, this is working. I'm sure this is working. Let's see. This is not. Where am I looking? This is the inputs, and okay, let's take a look. First of all, draw connections. This shouldn't fail. Then we go into our IO, because I remember somewhere around here I was using first, and this is wrong. This is not find. This is first. Damn it. So I blame Steve. Okay. Build solution. But now I need to come on. Delete this guy, not like that. Delete that so that it gets reset, and I need to find the database and delete the database. And clear, and let's hope it's working now. So test, test, test. This was the situation that we got error in. And where are you drawing from there? Okay, whatever. That can be fixed later. But yeah, that's working. Now where am I getting it from? Draw from here. My draw connection. Did I derp here again? Let's check. Line by line. If inputs null, any return input in inputs. If input dot any parent not, or input dot connection equals null, or connection list is null, or not any, continue for each parent in input parents. If the output is null, continue. List connection keys, input key equals input dot connection dot list, list of int output indices equals input key dot first, t goes into t dot has key for parent dot related node dot id dot values. For int I, yeah, I less than output indices count, start equals to parent dot outputs I position, end equals end dot position, the rest is irrelevant. So why are you behaving like this? This is weird. You shouldn't draw it like this, you know, sir. Okay. Let's take a look what is going on. No. Which one? Connection list? This one, I think. 0. Yeah, it's element 0. Okay, element 1, connection 0, connection 0. There we go. Okay. What? Sir? Okay, now he's drawing it properly. I'm confused. I'm totally confused. Okay. This is the last node. This should be the node before that. So if I make a connection from here to here. No, actually, that's not the one. Clear the whole graph. Create a graph. Okay. Create a node. And right now, this is the node. Then create another node. And it made on top. There we go. Why are you setting element 0? This index 0. Well, that's correct. Yeah, that's correct. Okay. This one, inputs, values, -1. -1. What the hell? I derped. I'm sure I derped. Let me see. We are sitting on the input schema. Active output. Where am I setting these guys to null? Yeah. Add key connection node. Okay, from the connection node, you're saying that input key equals to connection list. Get the connection nodes, related node ID, and daemon. No, actually. Yeah, no. I'm totally confused now. I'm literally confused now. Output index of node, parent graph, active output. Input key does not equals null, that is not null. input key that add value, output index. Well, here we can say debug.log node.parent graph dot related graph.id. No, what I'm doing. Dot parent graph dot active output. Let's see what we get. Whereas so we get something. But then this guy, now it's working. Interesting. Okay, it's element 1. Then why are you drawing it to the 0? Huh. Okay, let's track it. We are getting for each input we are getting its parents. Then inside the input we are getting the connection list. We are getting this guy. Wait. What's this thing? Phew. What is the, oh wow, look at me. Look at me, look at me. Inputs, related input. This should be related output. So first of all, damn it, related, I shouldn't do this like that. I just should rename it here, related outputs. And now everything by magic should work. Just in case, I double check it, and this is related outputs. Everything's reversed. Okay. Oh, no, actually, that is correct. Oh, here is the thing. This node schema has this. Test node, wherever it is, has this. Boom. And well, we don't have icons. We don't have show name. And this is new node input. That. And now in a schema, we have to say here inputs of 0 dot related input equals to related node dot inputs of 0, outputs of 0 dot related output equals to related node dot outputs of 0, and this will become 1. At least now I wouldn't get that nasty -1. And honestly, I'm not sure if that was the reason. Yeah, still. Okay. 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 Everyone's cool? Yep. So create something for me. And phew, still wrong. But at least now I should be able to track it better. And the inspector is not updating. Why is that? Okay. Yeah, at least now that's okay. Now. Look at here. This guy's output. Element 1 has a connection to the input 0. That's okay. And that's okay. This guy, its element 0 has no connection. That's okay. Element 1, wait, that's the input one. Okay, sorry. This guy's input, it's only have one input. It has a connection to the element 1. It means that this guy. Then why the hell are you drawing it from here? That means our output position is getting calculated wrong. The values are there, they are correct. We get the output indices. Input key This is bothering me now. Let me pause the video. You wouldn't believe me. The only problem was that when I was getting the start, I was using the index I. That's wrong. I need to get the output index of I. and that's the index of the outputs that we should draw it. And bingo. So if I have a test, I connect this guy to here, that behaves now. And I'm fairly sure if I have more than one input, that would work. Just for the sake of testing, I will add another input. Here, I don't care about the other graph yet. And I have to make these guys now, come on, test, and another test. And if I add this guy to here, and this guy to here, and the reason you are seeing it like this, let me delete. I created two nodes on top of each other. Draw a test, and if I draw this guy to here, it will work. And let's break the connection. This guy to here will work. This guy to this guy will work. Reverse connection breaking is working. Breaking the connection is working. There we go. And it's working. Okay. The only problem was this bad index at the start of the loop for the start position. It should be output index of I. Because if you think about it, I was getting the values of the outputs that is connected to this input, putting them inside the list, then looping through them to draw them, not the index. Yeah, I'm stupid sometimes. Anyway, in this episode, we finished drawing our connections and breaking our connections. Now, what's next? Well, if you noticed, when I draw this box like this, I lose this node's visibility. I don't have any way of moving these nodes around. And I hate it. So right now, honestly, we are almost finished with connections. So if I close all and come back to our node schema GUI, you will see that I have process events. This is what I will do in next episode. This process event will let us move the node around. And honestly, I should see why I'm not using this scheme properly. Yeah, because I'm not implementing it at all. That's here. Change style on behaviors. Well, I can say, yeah, you know, node default. Okay, then I will say if wait, I didn't add any of those. Okay, anyway, next episode I will process the events, then we will see what happens next. Until then, have fun everyone, bye bye.